recharging the Prius Prime after collision. The whole entire accumulator assembly was replaced, and if you look in my last videos, I show the old one and the new one out inside my hands. This is $2,600. $2,600 of a lot of complexity that could have been avoided, but you know, it's automotive, what can we say? All right, so just finished recharging it. I did the video on recovery several days ago. Was just going over it preliminary, looking for real quick anything big leaks. Using the UV light, I'm warming up my refrigerant leak detector to go over it. Now this gets cold. We got some frosty freeze here going on. So from this sensor right here, what's on the suction line attached to the low side, our temperature is at 37 degrees at that point right there. Our liquid line is 71 degrees. Our liquid line is 71 degrees. That's this wired sensor right out of the condenser. At this point right here, let's go to our software. So we got the field piece software here, and we are at 110 degrees at this point right here. So this is 110 degrees, and this is 71 degrees, 69 degrees at that point right there. Now let's take the temperature, 36 degrees right before. Now right before, this is like an old-fashioned POA valve, STV valve, something that was used by Chrysler and some of the vehicles back in the 50s and 60s. Almost faded out by the 70s, and like Rolls-Royce and stuff like that would use these. So let's take this off. This is the remote sensor, suction line, cold one. That's why it has the green, the little blue tag right there. Let's go after that valve. Now let's see what we got here. We're now, there we go, 20 degrees. 20 degrees right there. So this, after what I would always call in the old days a POA, positive pressure, or a STV valve, this is the valve that goes into the accumulator. This is on from the evaporator. It's coming down here. It's dropping down into, not evaporator, accumulator. It goes through the accumulator, has the desiccant in there, has the oil separator in there. Then it pulls off the top to pull vapor refrigerant with no liquid to go back to the compressor, and it's on its journey right here going back to the compressor that you see right there. So we're at 17 degrees just after the valve. Let's go back to the compressor and see what we have at the compressor, going back to the compressor out of the accumulator. So at this point is the pressure drop after the accumulator. Let's see if we pick up anything different. Stay steady, 17 degrees. Usually you see 1 or 2 degrees maybe sometimes drop. So that would be right there, right out of it. Okay. Now anybody who knows air conditioning, seeing temperatures this low would automatically go, there's something wrong, that's not good, but this is normal. So let's break out the infrared. Our camera, thermal camera. See those nice cold lines? That's what we got going on here. Here you can clearly see the accumulator assembly and all related. Oops, what happened to my thing? Start that again. I think I should have killed the light. My light on my phone is washing out the screen. I gotta move it in a way where I don't wash you guys out. So you can see the high side components. And I wonder how hot that is. That's pretty warm. I'm wondering if the solenoids, depending whether they're activated or not, will determine their temperature. So that solenoid is really hot. And that solenoid is connected to, that's the cool side right there. That's cold. That's like 60, 50 degrees right there. So right at that point, it's really cool. Oh, 48, 50. Oh, yeah, I was right. Right around in that area. You can tell I have a calibrated finger. And our solenoid. So this has an electric winding in it. It's nothing more than an electromagnet. It's an old-fashioned, old-school solenoid. Nothing special. So this is energized. You can tell that by its temperature. Here's another solenoid. That solenoid is not energized because it is not hot. This heat right here is what you see. Now this is really confusing here. It's really hard because remember, if in my previous videos I explained to you the problem with thermal temperature sensors and thermal cameras. Bright shiny aluminum gives you false readings. If I wanted to do this really correct, I would spray everything here. I'd clean it up and spray it down with black Weber flat paint. And with black Weber flat paint, you can take excellent readings. So our solenoid, located on the bottom side of what looks like an expansion valve there, because it looks like it has that adjustment in the bottom that you cannot see, like when you're setting superheat. Then on the other side, there's another solenoid. If I can get to it. Okay, this is a stepper. Okay, right here, I'm going to use the laser to point for you. If you could see that right there, that's a stepper for like an expansion valve right there, and that is not hot. Then there is a solenoid that we cannot see on the back here, and it is energized because I could see it where it's glowing really bright, right where my crosshairs are. So in this situation, under cooling mode, that solenoid back here that we only could see the bottom side of is energized because it's hot. This solenoid is energized. Let's go back to, now that's the stepper back there. So now you're looking at all the cold pipes going back to the evaporator in the back there. Let's not kill you with my light. And it's just too crowded for me to get a good aim on anything, even if I aim in on it with my laser. And that's our high side pressure, which on a day like today, that's a good old normal 90 degrees high side pressure is normal. There's nothing wrong with that. And let's see, come down here, out the dash. Our dash temperature is 40 degrees coming out the dash. So we're doing pretty damn good here. I'm sorry there's nothing more that I can show you guys on this one. But when this vehicle leaves here and after insurance pays off and all the paperwork is signed and everything, I get this assembly right here. They have it over in the box somewhere. Let's see, where is it? Somewhere they have it put away for me. But that $2,600 assembly is going to be on my workbench in a couple days. And I'll have all those valves, all the solenoids and the stepper valves. And all I got to do is I got to come across a total Prius Prime so I could get the rest of the piping work, the rest of the solenoids. I want to get the air heat box and evaporator and the compressor and everything like that, and accumulate and put a benchtop working model together. But that'll be for future videos, and that'll be a lot of work and some luck coming across some totaled out Prius Primes. Alright guys, that's all I have to show you for today. And well, I know let's throw this thing in heat mode. Okay. See, it's not cold. I think the engine temperature, unfortunately, I think I already warmed up the coolant. So let's go warmer. Throw this puppy into heat. Let's watch our temperature here. Yeah, I know it's not going to activate the heat pump because there's warm coolant and the temperature is not that cool, and there's no reason for it to kick the heat pump on when it already has some warm coolant. We're already at 100 degrees. I'm taking the temperature right here using the Bluetooth wireless probes. Funny. Hey, we still... Oh no, that's just the temperatures. I mean... Okay. Alright. Yeah, no, it's not, it's definitely not switching. See, with your fingers, you could diagnose whether or not the solenoids are on, because even with your fingers, you put your finger right there, and that wire wound coil, it almost burns your fingers. It's that hot. Let's see if I can get that one. That one's not as hot. That's about as hot as the aluminum. So right now I know this one is not energized because this one is the same temperature as this valve body right here, but this one's burning hot. So that's one thing about a solenoid. Another one is you can get a little piece of metal and go to the top here and touch it. It's like a magnet. It'll suck it in. Thermal camera. $140. $151, $149. That's how hot that is. See, in commercial refrigeration and air conditioning, we use solenoids like this. So this is really old school stuff, older than I am. And so coming on to automotive, it's nothing new. They just configure things just a little bit differently on the car, and it's going to confuse the hell out of technicians who've never seen it before. And do I get a good line? I don't really get a good line of sight down here. So you could see the one pipe, still cold, still running. Even though I have this on full heating mode, it is still cold, and it's still, I have it on full heat in the car, but look at my pressures. It's still running, the AC. The air conditioning is still running, the compressor is still running, but I have it on full heat inside. We're coming out 117 degrees out of the dash right now. Alright, so I'm going to turn it back over to cooling mode. It's hot as, yeah, it's nice and good here. Oh yeah, well, the AC is still on. That's why the AC on. Even though it's fully hot, the AC is on because I have it on. Let me turn it off. Boom. AC's off. And our temperature is rising. And our low side pressure is going up, our high side pressure is going down. It's off. So I'm going to stick it back into cooling mode, take my snapshot. Oops. Bring bring the temperature back down. Yep, coming out cool now. It's down into the 60s, 50s from 114. It has to cool down all that plastic before it can actually get cold again. So you see our supply air at 63 degrees because it was 114 degrees. So all the plastic in the heating duct and all the flaps and everything got hot. So even though it was very cold, it's at 30 psi. So we know it's cold. It's fighting to bring down all that hot plastic right now. It'll get there, but it just has to fight to do it now. And let's see. Nothing that I'm gonna pick up right now. So this is the fitting that I've been finding on Priuses to be wet and oily. And so is this lower one right there. You can see where I touched it. That was all black and oily. I touched it with my finger. That's why it's shiny right there. But this was complete. I'm going to clean it all off before it leaves here. And I'll clean all of the oil off that one there. This one here, and there's another one, attached one here. So when this comes, if it ever comes back and it's ever low, and if I ever see it again, I know I cleaned all this off. And if oil reappears again, well, then we know Toyota has a problem with some leaking O-rings. That's about it, guys. See you on the next one.